For example number 2, we have a slightly different orientation of our triangle. Again, it's not quite drawn to scale. And again, we're asked to solve for x. Immediately, we identify the hypotenuse, and then the a and b can be arbitrary. It's just the remaining side. So remember that the hypotenuse is the longest side. It's across from the 90-degree angle. This little box means that it's a 90-degree angle. To solve for x, again, I just say a squared plus b squared equals c squared. All right. So I'm going to plug this stuff in. A this time is x. B is 7. And c is 14. Now I want to solve for x, so what I'm going to do is I'm going to square everything. So I know this is 49. And 14 squared, I don't know what that is. Is that like 196? Whoops. I got my I got a calculator on my phone. So I'm going to say 14 squared, and that gives me 196. So 14 squared is 196. And then I have x squared here. So what I did is I just expanded this out, Remember, 7 squared is the same as 7 times 7, which equals 49. Also, 14 squared is 14 times 14, which equals 196. Okay, so that's what we're doing on the calculator. Now to get x by itself, I'm going to subtract 49 to move it away to the other side. Whatever I do on one side, I have to do on the other. So just to make sure I don't make an error, I'm going to do this on my calculator. So I'm going to say 196 minus 49, and that gives me an answer or difference of 147. So on this side of the equal sign, I get 147. And then on this side, I get x squared. Again, I'm going to take a square root. However, I know that 147 does not, it does not have a integer square root. In other words, if I plug this in my calculator, if I say the square root of 147, like that, and I hit enter, see, I get a decimal. It's 12 point something, right? Because I know 144 is 12 times 12, right? So it doesn't work out that way. But I'm probably going to have to simplify this. So what I do know for sure is that the x squared and the square root, remember, I want to identify this. If I say x squared, this is squared. This symbol here represents a square root, which is the opposite operation. These are two different things. A lot of times students think that when you say square, that this is square, and this is square, one word, square, which means you multiply it by itself 2 times. This is square root, which is the inverse operation. So when you square root a square, you're undoing the square, so you're left with x. And then I got this thing here, which is a decimal. Now in the textbook, they want us, and I got to teach you this, is to simplify this. So to simplify a square root, what you have to remember is you got to think of the perfect squares. So 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. Now I think 49, believe it or not, actually goes into 147. So let's just see. That's a picture of my daughter. I got my... So if I take 147 and divide it by 49, I think it goes into it 3 times. So what I'm going to do is I'm going to think of this as x equals 49 times 3. Now, one of the properties of square roots is I can actually separate that. 49, the square root of 49 times the square root of 3. These two lines mean the same thing. Now, the reason I divided it by 49 is because I know that 49 is a perfect square, which means I could take the square root of 49. So when I take the square root of this, I'm taking the square root of this and I undo the square. So then this now becomes 7 root 3. Notice that I said root 3. Okay? And that's our simplified answer.